Hello everyone. In this video, I'll solve previous year JEE main questions from the chapter Linear Inequalities. See the first question, the solution set of this inequality. So the given inequality is modulus of 3 minus 4x is greater than or equal to 9. I have to find the solution set of this inequality. Now to find the solution set of inequalities involving modulus functions, mod x greater than or equal to a implies so x is greater than or equal to a or x is less than or equal to minus a. This is the solution set of inequalities involving modulus function. Mod x greater than or equal to a means x can take any values greater than or equal to a, or x will take any values less than or equal to minus a. So as per this inequality, when you apply here, you will get in the place of x you have 3 minus 4x. So 3 minus 4x greater than or equal to a means 9, or 3 minus 4x less than or equal to minus 9. These are the two possibilities. So we have to solve these inequalities. So this is take 4x to the other side. 3 minus 9 greater than or equal to 4x, or this can also be written as 4x is less than or equal to minus 6, x is less than or equal to minus 6 by 4. So x is less than or equal to minus 3 by 2. This is one possible solution. Or 3 plus 9 less than or equal to 4x, or 4x is greater than or equal to 12, x is greater than or equal to 3. X is less than or equal to minus 3 by 2, or x is greater than or equal to 3. You have to combine these two to get the solution. So first inequality, x is less than or equal to minus 3 by 2. Less than means to the left of the number. Left has minus infinity. So the solution set becomes, solution set is minus infinity comma minus 3 by 2. 3 by 2 is closed because the inequality is slack. Then or means you have to use union because it is the solution is either this or this, therefore or means union. X is greater than or equal to 3. 3 greater than or equal to 3 means to the right of the number, right has plus infinity. So 3 comma infinity. So this is the solution set. Therefore the solution set of this inequality is this. Second option is the answer. See the second question, the value of x for which this inequality, there are two inequalities. This is called a system of inequalities. You have to solve system of inequalities. System of inequality means first solve this inequality, get its solution, then solve this inequality, get its solution. The common solution becomes the solution of the system of inequalities. So let me write the question. This is x minus 3 by 4 minus x less than x minus 1 by 2 minus x minus 2 by 3. Another system is 2 minus x greater than 2x minus 8. So let us solve these two inequalities first. So here let us solve the first inequality. 4 is LCM, x minus 3 minus 4x less than 2, 3 is 6 is the LCM. Therefore you will get here cross multiply 3x minus 3 minus 2x minus of minus plus 4. So let us simplify this first. So this gives you x minus 4x is minus 3x minus 3 by 4 is less than 3x minus 2x is x plus 4 minus 3 is plus 1 by 6. Now you can cross multiply this. You will get it as minus 18x minus 18 less than 4x plus 4. All x terms on one side. So you will get minus 18 constant to this side, 4x plus 18x. So this is minus 22 less than 22x. So you will get 22x greater than minus 22, x is greater than minus 1. This is the solution of the first inequality. Now let us solve the second inequality. 2 minus x, all x terms on one side, 2 and constants to the other. 2 plus 8 greater than 2x plus x. 2 plus 8 is 10, which is greater than 3x. So 10 greater than 3x is same as 3x less than 10. X is less than 10 by 3. This is the second set. So now common solution means x is greater than minus 1. Greater than minus 1 means to the right of minus 1. There is 10 by 3, approximately 3.3 somewhere over here. 10 by 3 if I take. Less than 10 by 3 means to the left of 10 by 3 up to infinity. Now where is the common solution? Because it is system of inequalities means because system of inequalities means we need the common solution. Both brackets will combine at this place. That means the common solution x belongs to minus 1 to 10 by 3. And open bracket because the inequalities are strict. Therefore, here the second option is the answer. See, third question, you have to get the solution set of this inequality. Inequality involving modulus function mod x minus 1, then plus mod x minus 2, plus mod x minus 3 greater than or equal to 6. By considering the values of modulus function, you can solve this, or else you can verify with the options, that is quick method. You have every option has here 0, 4, another option minus infinity to minus 2, union 4 to infinity, another is minus infinity to 0, union 4 to infinity. Last option is none of this. So out of all these three options, see, in this option it is 0 is included, in this option 0 is not included, here also 0 is included. So you first check, is 0 a solution? Put x equal to 0 here. Mod of minus 1 is 1, plus mod of minus 2 2, plus mod of minus 3 3, 3 plus 2 plus 1, this is equal to 6, 6 equal to 6. So it is a solution, 0 is a solution. Therefore, this can't be the option because it is not having zero solutions. It means all possible solutions. This is also one of the solution, but it is not including all possible solutions. Next you check, is 4 a solution? X equal to 4. Yes, substitute 4 minus 1 3 plus 2 plus 1. This is also 6. 6 equal to 6. This 4 is also a solution. Now 0 to 4, either this or this option. This includes 5, 6, 7 also. You can check x equal to 5. Is it a solution? So x equal to 5. 5 minus 1 4 plus 3 plus 2, which is equal to 9, which is greater than 6. Yes, this is also a solution. Therefore, it includes only up to 4. Therefore, this can't be the solution. Hence, solution set is this, minus infinity, 0 to 4 to infinity. Second option is the answer. Next, fourth question, solution set of the inequality mod 3x plus 2 less than 1. So this is an inequality involving modulus function. Inequality involving mod function, mod x less than a, implies x is always in between minus a to plus a. This is the inequality to be remembered. So in the place of x you have now 3x plus 2. So 3x plus 2 should be greater than minus 1, less than 1. So now it is a double inequality. You have to solve double inequality. Subtract 2 on both sides. Minus 2 less than 3x plus 2 minus 2 less than 1 minus 2. So this minus 3 cancels, 3x greater than minus 1. What next is divide by 3. So when you divide throughout by 3, minus 1 less than x less than minus 1 by 3. This is the solution set. So x belongs to minus 1 comma minus 1 by 3, open interval, because the inequality is strict. See here, this third option, minus 1 comma minus 1 by 3, it should be in interval form. Solution of any inequality involving modulus function is always a real number. So we want the all possible solutions. This is set containing minus 1 by 3 comma minus 1. It has only two possible solutions, but this contains all possible solutions. See question number 5. Solution of this inequality mod x plus 3 plus x divided by x plus 2 greater than 1. Either you can consider two cases of mod x plus 3. One is x plus 3 and minus of x plus 3. When x plus 3 is greater than or equal to 0, x plus 3 is less than 0. Then the simplification, or else you can check with the options as well, because every option is in this form. Either it is closed or open. So first you check, is x equal to minus 5. Is it a solution? So minus 5, put it over here. Minus 5 plus 3 is mod of minus 2 is plus 2. Uh, x is equal to minus 5 divided by minus 5 plus 2 is minus 3. 5 minus 2 minus 5 is minus 3 by minus 3. Minus 1 greater than 1. So it can be a solution. So minus 1 can't be included. Here also it is included. Here also included. So it can't be answer. So this is the possibility. Hence this itself is the solution. You can save your time by checking with the options. Similarly, you can check -1, x equal to -1. Is it a solution? -1 plus 3 is 2. 2 minus 1 by -1 plus 2. 1 by -1 plus 1 is 1. 1 greater than 1. This is also not possible. Hence, 1 cannot be the solution. So, hence -1 can't be the solution. -1 also open. Therefore, this is the option C. We can check with the -2's, x equal to -2, or any value in between these two. -3 plus 3 is 0. -3 divided by -3 plus 2 -1. This is 3 greater than 1. Yes. This is in between -5 and -2. To make sure that this itself is the answer. We have taken x equal to -2, which is in between -5 and -2. We got the inequality true. Hence, this is the solution. So, C option is the answer. Now see the sixth question. Solution of this inequality: 2x plus 1 into x minus 3 into x plus 7 is less than 0. So we want the solution of this inequality. Now to solve this inequality, we will use the wavy curve method. This is the shortcut method to solve the inequalities which are having the product factors. See, for example, to apply wavy curve method, you should have the factors x minus a1, x minus a2, x minus a3, so on up to x minus ak, either less than 0 or greater than 0 in this way. So x term must be first always. So in all the three cases, x is first, then you have some constant term. Okay, now when you equate this to 0, so 2x plus 1 equal to 0, x equal to minus half you will get. So possible values of x which makes the inequality 0. This is x equal to 3 and x equal to minus 7. Now these are the three key points. So one is minus half, one is minus 7, and another is 3. Out of these three, you have to find out the largest one. The largest is 3. Now to the right of this largest value, you have to always put plus. Then alternative plus and minus. So find the largest. To the right of the largest, you always have to put plus, then minus, plus, minus, alternative. Then here check the inequality. The product should be less than 0. Less than 0 means negative. Where you will get the negative sign, that is at this place. Hence solution is minus infinity comma minus 7 union minus half comma 3, because within this interval the solution is negative, so it is less than 0, and the solution set is minus infinity comma minus 7 union minus half comma 3. Union because combining those two solutions to get all the possible solutions. The sixth question. Next, seventh question. Solution of the inequality mod x minus 1 greater than or equal to mod x minus 3. By considering two different values, you can solve it. If it is lengthy, then you can go with the method of verifying with the options. See, x is less than or equal to 2 is given, x is greater than or equal to 2, and x is from 1 to 3 is given. So less than or equal to 2 means 1 comes. Check with 1. X equal to 1. This is becomes 0 greater than or equal to. Modulus minus 3 is 3. 0 greater than 3. This is false. So x equal to 1 can't be the solution. 1 is within this. This option goes. This option also goes. X is less than or equal to 2 means. Therefore, only remaining option is this. Hence, the solution set is x is greater than or equal to 2. Next, eighth question. The value of x for which 2x minus 3 by 3x minus 5 is greater than or equal to 3 is. You have to get the solution of this. You can apply the same wavy curve method for this also. X equal to 3 by 2. But before applying that, you have to get here 0 on the left hand side, on the right hand side. So first let us simplify that inequality. Bring that minus 3 to this side so that you will get 0 here. Then only you can apply wavy curve method, not before that. So 2x minus 3 minus, take LCM, 9x plus 15 divided by 3x minus 5 greater than or equal to 0. So you will get 15 minus 3, 12 minus 7x by 3x minus 5 greater than or equal to 0. Now x always first. For wavy to apply wavy curl method, x is always first. So take minus common. 7x minus 12 by 3x minus 5 is greater than or equal to 0. So to avoid this minus, multiply throughout by minus. When you multiply by negative number, inequality reverses. So you'll get 7x minus 12 by x 3x minus 5 is less than or equal to 0. So possible values of x are x equal to 12 by 7 and x equal to 5 by 3. So one value is 12 by 7, another is 5 by 3. Out of these two values, largest is 12 by 7. So you will get here 12 by 7 and here 5 by 3 on a number line. So this is the largest. To the right of the largest value, you have to put plus, minus, plus. Now see the inequality. In the final form, the inequality is asking for less than or equal to 0. Therefore, negative, where it comes within this interval, and it is slack inequality, you have to include the end points as well. Therefore, x belongs to closed interval 5 by 3, 12 by 7. But see here, when you include the endpoints, 12 by 7 can also be included. There is no issue. But when you include 5 by 3, denominator becomes 0. So x can't be equal to 5 by 3. Therefore, though this is the solution at the first glance, but you have to re-verify it. This makes the solution as open interval 5 by 3, 12 by 7 closed. This is open because we can't include this point. If you include, becomes denominator 0. Therefore, option B, 5 by 3 open, 12 by 7 closed. See the ninth question. Let A equal to x belongs to set of all x such that x belongs to R and mod x plus 1 is less than 2. This is the question. And B equal to the set all real such that mod x minus 1 is greater than or equal to 2. Which of the following is not true? That we have to find out. Now, to get the answer, we have to check with every option. To check with every option, first we have to get the set A, get the set B. So what the set A is? It is the solution of this inequality. You know that mod x plus 1 less than 2 inequality solution is mod x less than A. Means x is greater than minus A less than A. This property of modulus function has to be applied. So x plus 1 greater than minus 2 less than 2. X is greater than, next subtract minus 1 on every side here. Then this minus 1 plus 1 cancels. Minus 2 minus 1, x is less than 2 minus 1. So x is greater than minus 3 less than 1. So A equal to all those real numbers which lie in between minus 1 and minus 3 and 1 is the set A. So now we got the set A. Similarly, we have to get the set B. Set B is mod x minus 1 greater than or equal to 2. We have the solution. Mod x greater than or equal to A means x is greater than or equal to A, or x is less than or equal to minus A. In the place of x, you have x minus 1 greater than or equal to 2, or x minus 1 less than or equal to minus 2. X is greater than or equal to 3, or x is less than or equal to minus 2 plus 1 minus 1. So here solution set B equal to closed interval 3 to infinity union minus infinity comma minus 1 closed. So on a real number line 3 to infinity, this full solution set B is nothing but, and another is 3 is also included, and B another value is minus infinity to minus 1. Minus 1 is also included. So the same set can also be written as B equal to R minus open interval minus 1 comma 3. This is also fine because B includes everything, all those real numbers starting from 3 to infinity and minus infinity to minus 1. Therefore, only these real numbers are left. So, from the entire line, if you subtract this, cut down this part, then you will get the B. That is another way of writing B. Now, to which of the following is correct? Is not true. To check that, you have to check with each and every option. See the first option, it is asking A minus B equal to minus 1 comma 1. Okay, we have to verify this now. So A minus B, A is minus 3 to 1. So A is minus 3 to 1. This is your A. Okay, and B is this minus infinity to minus 1, then 3 to infinity. Okay. So from this A minus B means what? From this entire A, I'll mark it in red ink. From this entire A, you have to subtract B. You have to subtract, means you have to remove that B. So here it is B. Remove this part. And B is from starting from here to here. So there is nothing to remove here. So only from this part, if you remove B, so then what remains? You are remained with this part minus 1 to 1. Therefore, A minus B equal to minus 1 comma 1. This is correct. First option is correct. Now you have to check with the second option. Second option says that B minus A equal to R minus 3 comma minus 1. Here itself you can conclude this is wrong, because you can't have an interval with the largest value first and the smallest value next. A comma B, interval is always written A comma B, where A is less than B. Okay, or else you change this to minus 3. Let us see. Minus 3. B minus A equal to R minus minus 3 comma minus 1. So let us find out B minus A. Now to find out B minus A, look here. B is minus 1 to infinity, one value, and another is 3 to infinity, that is this value. Full 3 to infinity, minus 1 to minus infinity, and 3 to infinity. 3 is included. From this B, you have to subtract, you have to remove A. What is your A? A is starting from minus 1. Here it is open. A is minus 3 to 1. So minus 3 comes somewhere over here. Minus 3 to plus 1. Okay. So here this is in red ink. Minus 3 to 1. So from this entire B, you have to subtract this red part. Okay. From the B, if you subtract red part, so it is, we are removing this part, because it is in B minus A means what? Only B. Only it should be in B. It shouldn't be in A. But this part is, look here, black bracket as well as red bracket combined. Means it is in B. This is your B. This is your A. Correct? No, it is in both in B as well as A. So I have to remove that. So B minus A equal to minus infinity to minus 3. Correct? No, minus 3 is closed, because minus 3 is in B, that is here, but minus 3 is not in A. Okay, the all the B minus A means what? All the elements of B which are not in A. So minus 3 also comes within B minus A. So minus 3 is not in A because it is open interval. Next, there is nothing to subtract from B at this end, because it is not having any elements of A here. So it everything is included here. So union 3 to infinity. Therefore, B minus A means it includes all those values starting from minus infinity to minus 3. Minus 3 is also included, and 3 to infinity. 3 is also included. This is your B minus A. So what is left out? So B minus A equal to, it is same as R minus open interval minus 3 to 3. This actually should be the answer. But what they had given, minus 3 to minus 1, or else even if they have given you directly 3 comma minus 1, that is also wrong. This is also wrong. So second option is not correct, because as per the second option, B minus A has to come out as R minus minus 3 comma 3 open interval, but that is not given, hence it can't be the answer. It can't be true. So this is the option which is not true. You can check with the remaining 3 options as well. So that is for our understanding. So you can check with A intersection B. What is A intersection B? A and common elements. A is minus 3 to 1. So check here. A is minus 3 to 1, red colored, and B is minus infinity to minus 1, here this bracket, and then 3 to infinity. Which are the common elements? Common elements starting from here. So that is minus 3 open, minus 3 open, because 3 minus 3 is not in A. It is open. So we have to put open. Minus 3 to 1. So common element is only this region. So minus 3 to minus 1, which is closed. Minus 1 is in A as well as in B, both in A and B, because in B it is included. So minus 3 to minus 1, here in this part you have red as well as black color. Hence, this is correct. Third option is correct. Now the last option is A union B equal to R minus closed interval 1 comma 3. Let us verify this also. A union B. When you combine A and B, what will you get? A is this red colored one. So minus infinity to 1 open union. Then when you combine 3 to infinity. So minus infinity to minus 1 is A is B, but here this and this together, minus infinity to 1, 1 is open, and 3 to infinity, 3 is closed because it is included in B, therefore 3 is closed. But as per R minus 1 to 3, this region is R minus 1 is closed because 1 is not here, so 1 has to be here, 3 is here, so 3 is open. So R minus closed interval 1 comma 3. Fourth option is also correct. See the 10th question. Solution of the inequality x is greater than 1 minus x is. This is the question. So we know that term within the square root should always be positive. Then only the square root function is defined. So we have here 1 minus x must be greater than 0. So if this is positive, the square root of positive number is always positive. So this answer is always greater than 0. So this implies x is always greater than 0. This is one condition we got on x. And one more, you have the term within the square root is greater than 0. So 1 greater than x, x is less than 1. This is another. When you combine these two, you will get x is greater than 0, less than 1. So this is one condition. Next, to get the solution set, this is a square on both sides. X square is greater than 1 minus x. You will get a quadratic inequality, minus 1 greater than 0. Find the roots of this quadratic. So you will get the factors as x equal to minus b plus or minus square root of b square minus 4ac divided by 2a. So this gives you minus 1 plus or minus 4 plus 1, 5 by 2. These are the possible roots of this inequality. So you will get now minus 1 plus root 5 by 2, one root, or minus 1 minus root 5 by 2, another root. So this is negative. We already know that solution must always lie between 0 and 1. Solution should be positive. So this can't be the solution. So another possibility is x is greater than 0 already we have. But now we got that this value root 5 minus 1 by 2. This is positive. So root 5 minus 1 by 2. This is already greater than 0. And this is less than x and less than 1. Because this value finally it will be less than 1. Hence solution set is x belongs to root 5 minus 1 by 2 comma 1 as per this inequality. Next 11th question, the product of all the solutions of the equation. This is an example for equation. Mod of x minus 2 whole square minus 3 into mod of x minus 2 plus 2, which is equal to 0. We have to get solution product of all the solutions. First let us find out the solutions. You can take this mod x minus 2 as y. Then you can replace this by y square minus 3y plus 2 equal to 0. So y square minus 2y minus y plus 2 equal to 0. Factorize y minus 2 minus 1 into y minus 2 equal to 0. So y equal to 1 or 2. Okay, so y equal to 1 or 2 means mod x minus 2 equal to 1 or mod x minus 2 equal to 2. So mod x minus 2 equal to plus or minus 1, x minus 2 equal to plus or minus 2, x equal to 1 plus 2, 3, minus 1 plus 2, 1, or x equal to 2 plus 2, 4, minus 2 plus 2, it is 0. So these are the roots of this equation. We want product of roots. One of the root is 0. Therefore, product of roots will be equal to 0. See, 12th question. We need to solve this inequality. X plus 4 by x minus 3 less than 2. So we can apply wavy curve method, but to apply the wavy curve method, you know that one thing is in the factors x must be first, that is there. But on the right hand side, it should be 0. So it is not so. X plus 4 by x minus 3 minus 2 less than 0. Don't cross multiply because it won't give you all possible solution. Only one set of solution it gives you, because x minus, if cross multiplication means x not equal to 3. X not equal to 3 means x less than 3 or x greater than 3. Two cases will come. You have to separately find for two cases. Instead of that, better you take 2 to the left hand side and take LCM. X plus 4 minus 2x plus 6 divided by x minus 3 less than 0. So this gives you minus x plus 10 by x minus 3 less than 0. X should be first always, and its coefficient must be positive. So take minus outside. X minus 10 by x minus 3. So here there was a minus. Now to get rid of that minus, it becomes greater than 0. So x equal to 3 or x equal to 10. So two values, one is 3, another is 10. Largest is 10. To the right of largest you put plus, minus, plus. Therefore this inequality is greater than 0 we got. Positive comes within this. So minus infinity to 3 union 10 to infinity. This is the required solution set. Minus infinity to 3, 10 to infinity. First option. 10 is open, here 10 is closed. So 10 is not closed because inequality is strict. Therefore first option is the answer. See now 13th question. 13th question is value of x for which x minus 1. X minus 1, x minus 2, 1 minus 2x is greater than 0. So to apply wavy curve method, greater than 0. On the right hand side you have 0. Your left hand side, x should be first. X minus 1, x minus 2. It is 2x minus 1 less than 0. Because we have taken minus outside. Then multiplying by minus changes the inequality. So x values, x equal to 1, x equal to 2, x equal to 1 by 2. So draw on the number line. One is half, another is 1, another is 2. Largest is 2. To the right of the largest, plus, minus, plus, minus. What the inequality says? Less than 0. Negative. Where comes negative? Minus infinity to half, union 1 to infinity. So minus infinity to half, union 1 to 2. 1 to infinity, no? 1 to 2. So option C is the answer. Next, 14th question. See, 14th question says solution of the inequality x minus 1 whole square into x plus 4. X plus 4 is less than 0. So this is the product of two inequalities. No need to go with the wavy curve method because it is directly understood. X minus 1 whole square. Square of a number is always positive. Therefore, positive into negative, then you will get negative because it is less than 0, they have asked. So this is positive. No chance of this becoming negative. So only possibility is x plus 4 must be less than 0, which implies x is less than minus 4, means minus infinity to minus 4. This is the solution of the inequality. Now see last 15th question. 15th question says value of x satisfying mod x minus 1 less than or equal to 3 and mod x minus 1 greater than or equal to 1. So we have to make use of the inequalities. Mod x less than or equal to a, mod x greater than or equal to a. Here it is x less greater than or equal to minus a to plus a, x greater than or equal to a, or x less than or equal to minus a. So this gives you x minus 1 greater than or equal to minus 3 less than or equal to 3. X is greater than or equal to, add 1 on both sides. Minus 3 plus 1 is minus 2, less than or equal to 3 plus 1 is 4. Here x is x minus 1. In the place of x you have x minus 1 greater than or equal to 1, or x minus 1 less than or equal to minus 1. X is greater than or equal to 2, or x is less than or equal to 0. Here solution is 2 to infinity union minus infinity to 0, and here the solution is minus 2 comma 4. So on the number line what you will get is minus 2 and 4. This is the solution set of the first inequality, minus 2 to 4. And here 2 to infinity. So 2 somewhere over here, 2 to infinity, and minus infinity to 0, minus infinity to 0. This is the solution of the second inequality. And means we need the common solution. Common solution means where both black and this blue lines meet. So that is minus 2 comma 0. 0 is included in both the cases, so 0 is included. Minus 2 is also included in both the cases, so minus 2 is also included. And union, then 2 to 4. 2 is also included here, 2 is included here, 4 is also included in the both cases, so closed interval 2 comma 4. This is the solution. So minus 2 comma 0, both are closed, 2 comma 4, both are closed.